Hello viewers, in today's class we are going to learn about the concept of critical points of a function, right? We generally study the concept of critical points in maxima and minima. So let us take a function y is equal to f of x. Now the definition of critical points is the values of x for which f prime of x equal to 0 or f prime of x does not exist are called as critical points. So let us first of all elaborate the definition of critical points. Now let us take this function f of x is equal to x square. Now this is a quadratic function. Now let us differentiate this function. So f prime of x is equal to 2x, right? Now the definition of critical points, it states that the values of x for which f prime of x is equal to 0. It means let us equate the derivative equal to 0, right? So we equate f prime of x equal to 0 in order to obtain the critical point. So we have 2x is equal to 0, so x is equal to 0, right? Now here x is equal to 0 is the critical point of this function, right? Now we know that the graph of this function, it looks like this, and this is the point x is equal to 0, and this point is the critical point for this function. Now let us take one more example. Here we have the function f of x is equal to x square minus 4x plus 3. Now this is also a quadratic function, and let us differentiate it. So f prime of x is 2x minus 4. Now in order to obtain the critical point, we have to equate f prime of x is equal to 0. So 2x minus 4 is equal to 0. So 2x is equal to 4 and x is equal to 2. So x is equal to 2 is the critical point for this function, right? Now viewers, here the important thing about critical point is that here we have two conditions, right? The first one is that the values of x for which the derivative is equal to 0, right? So the first condition for the point x to be a critical point is that the derivative is equal to 0 at that point, right? And the second condition is that the derivative does not exist, right? The derivative does not exist at that point. So let us summarize it. The values of x for which the derivative is either equal to 0 or the derivative does not exist is known as a critical point. Now let us take the example where the derivative does not exist, right? So let us take the function f of x equal to square root of 1 minus x square, right? Now here let us first find the critical points. So we differentiate it. So f prime of x is 1 over 2 times square root of 1 minus x square, and then by chain rule we have here minus 2x. So this is 2 and 2 get cancelled. So here we have minus x over square root of 1 minus x square, right? Now in order to obtain the critical points, let us equate f prime of x is equal to 0, right? So here we have minus x over square root of 1 minus x square equal to 0. So if we solve it, we get x equal to 0. So here x is equal to 0 is the critical point, and so x equal to 0 is the critical point for this function, right? Now here let us now observe the derivative, right? So the derivative is f prime of x is equal to minus x divided by the square root of 1 minus x square. Now viewers, here we see that when 1 minus x square is equal to 0, right? This is the square root of 1 minus x square is the denominator of this derivative, and if the denominator is equal to 0, then f prime of x, that is the derivative, does not exist, right? So here we have square root of 1 minus x square is equal to 0, or 1 minus x square is equal to 0, and if we solve this equation, we get x is equal to 1 and minus 1. So we arrive at the conclusion that whenever x is equal to 1 or x equal to minus 1, the derivative, that is f prime of x, does not exist, right? It does not exist at these 2 points. So f prime of 1 or f prime of minus 1 does not exist, right? So therefore we see that here x equal to 1 and x equal to minus 1 are the other critical points of this function along with x equal to 0, right? So what we have concluded, so we have concluded that for this function the critical points are x equal to 0 and x equal to 1 and x equal to minus 1. So here at x equal to 0 the derivative is 0, that is for x equal to 0 f prime of 0 is equal to 0, and at these 2 points the derivative does not exist, right? So f prime of 1 or f prime of minus 1 does not exist. Now let us take this example to find the critical points of these 2 functions. So let us take the first one. Here we have y is equal to f of x equal to x cube minus 6x square plus 12x minus 8. Now in order to find out the critical points, let us differentiate this function. So dy over dx is equal to 3x square minus 12x plus 12. So this is the derivative of this function. Now in order to obtain the critical points, so we write here for critical points the derivative must be equal to 0, dy over dx is equal to 0, or we can also write f prime of x equal to 0. So we have 3x square minus 12x plus 12 is equal to 0, and this can be further simplified as x square minus 4x plus 4 is equal to 0, dividing throughout by 3, and we can write this equation as x minus 2 whole square equal to 0, right? Now if we solve this equation, we get x equal to 2. So x equal to 2 is the critical point for this function. Now let us take this problem. So here we have this function. So let us differentiate it. So dy over dx is 5x raised to 4 minus 20x cube plus 15x square, right? The derivative of 1 is 0. Now we have this expression for the derivative, and we can further simplify it by writing 5x square, taking 5x square as common. So we have here x square minus 4x plus 3, right? Now if we factorize this quadratic term, we simply get x minus 1 and x minus 3, right? Now to find out the critical points, we should equate this derivative, that is dy over dx is equal to 0, right? So this is for critical points. Now we equate this expression to 0, so we have 5x square times x minus 1 x minus 3 equal to 0, and if we solve this equation, we get x square times x minus 1 x minus 3 equal to 0. So this gives x equal to 0, x equal to 1 and x equal to 3, right? So the critical points of this function are x equal to 0, 1 and 3.